vertical asymptotes as long as the factors aren't the same in the top and the bottom.
Okay.
If they are the same, it's a whole. Maybe you saw that at some point in the course. So you said x plus 4 equal to 0, x minus 2 equal to 0, x equals minus 4, x equals 2.
So that's the vertical asymptotes.
Yes. You could also graph this. I don't know if you have that allowed, but if you can, you would see that as well on the calculator.
All right.
Horizontal asymptote is a little bit different. There's a couple of cases to consider. It is based on the equation. So let me go grab that equation one more time. I had a student actually give me some good language to use on this. So I'll try that with you here. I think it's really helpful. You have to decide whether it's top heavy or bottom heavy.
Or bottom heavy.
Yeah, and in this case, it's bottom heavy because of that squared there. So since it's bottom heavy is always y equals 0.
And so the square or like the power is
yes.
It determines like
Bottom
just how heavy. All right. So
yes. If it's equal, that's when you have to use a ratio. It's y equals like a over b, where a and b are the leading coefficients, which this one is not, but I can come up with one if you want. This one is 0.
Okay. Wait, so
maybe I should have saved this for another problem. and like let me give you one here. Let's say it was f of x equals 3x squared minus 2x plus 5 over 6x squared plus 4. This would be 3 over 6 for the horizontal asymptote, because it's the top and bottom heaviness are the same.
Okay. Right.
All right, so I got 6 up. You tell me if you want us to do this or not.
I'll do 6, yeah.
6, okay.
So
I have to snip this in pieces. It's kind of, they made the graph very large. Have you been working the questions backwards with the answers much, or just working them with, kind of like, let me ask it differently. This problem really would be better served to use the answers, but I don't want to do that if that's not how you're doing it.
It's a strategy, I guess.
Yes.
I'd say if I could pick it up, I tend to just work it through.
Okay.
Yeah.
So the bottom is where the vertical asymptote occurs. Where is the vertical asymptote here?
The vertical is -2.
X equals -2. So you have to back the 2 over, and that becomes your bottom.
Right.
Because the horizontal is, well, the next thing we do here is use the x-intercept, and that's from the numerator. The x-intercept is at -1, and back that off each side for that. Okay. But this may be the answer. It may not be, because it's actually kind of encoded into D and A. And we need to look for something else to give us the difference between them.
Right. Okay.
And trying to look here to see what they have done here to do that. Actually, the last little piece is that the horizontal asymptote is at 1. And that is the ratio of the leading coefficients here. Whereas for D, problem D, your leading coefficients are 1 and 2. So it would be at y minus 1/2. So it looks like A is the best choice there.
Okay.
So you really can't get away completely from looking at the answers, but you can do a little bit to.
Yeah. I just, because sometimes like I can't recognize like if I should be reverse engineering, I guess.
It depends. Yeah.
Right.
Like everything else. It depends. All right. Number 7 here.
Sure.
Which one of the following represents a rational function whose graph has a vertical asymptote at 2, a vertical asymptote at -3, and a horizontal asymptote at 0. Okay, so we know the vertical asymptotes are on the bottom. So x equals 2 corresponds to x minus 2. X equals -3 corresponds to x plus 3. So you have to be able to quickly FOIL that, and I think you can.
Right.
Let me know what you come up with on that one.
X squared plus 3. Or, oh, wait a minute. All right, x squared plus x minus 3 or minus 6.
Yes. So what reason you might do that is then you can look at the answers and say, okay, not A, and not E. It doesn't help a ton, but it gets a little bit down. All right. The fact that it has a horizontal asymptote at 0, that means that it's bottom heavy.
Okay.
So out of B, C, and D, which one is bottom heavy? Which ones? If there's more.
C, right?
Yeah.
Okay.
There's your answer.
Okay.
All right. So 8, transition to kind of businessy questions. You'll see a little bit. This one's pollutants, I guess. Take that back. You tell me if you want us to just keep going in order or
Yeah, for now you can go in order, and
okay.
then I'll
Yep.
start staggering later on.
Sounds good. All right. A lot of words here. You got to find f of 90. F of 90 means to put 90 in for P. So if you got a calculator handy, go ahead and see if you can figure that out.
Right.
And then we'll talk about the interpretation.
Just okay.
The top and bottom have implied parentheses, meaning that you want to do the calculations with parentheses around them, or
Yeah.
just be very careful if you're not doing that.
Okay, I got 1,440.
Good. You can see that D and E have that. So then you go look and say, well, what's the difference between D and E? And it's right here. It's this amount. P is 90%. You see that's the same in both. So you got to go back to the units of C. The units of C say in millions of dollars. So it's 1440 millions of dollars. So they're not off by 1 0, they're off by 6. So just choose the one that's more or less what you think it is. You don't have to overthink like, oh, is it 6 zeros? Is it 5? It's a big number.
Yeah.
All right. Number 9 here.
Inverse.
So the inverse is all about understanding how the units play in when you're looking at something like this. So it's referring back to the previous problem. So it's what might be good to do is P in the original problem, which is percentage of pollutants, produces the cost C in dollars. So I guess I should put that, go backwards that. So now when we're doing the inverse, it's going the other direction. The input is C to produce P. So this 480 is the input now. It's the cost.
Yeah.
So a couple ways to do this. You could actually determine the inverse, which would take a really long time. You can also recognize that if you know this is the cost, there's only there's 3 here that have the right cost. This one, and this one. And then I guess you do actually have to calculate it. Darn. Okay. That's a little bit tougher. So to do
Mm,
that, you go back to the original equation. And you're trying to figure out, well, where does this equal 480? So you could try solving this, or you could see, well, does 75 work? Or does 25 work? Or does 202.1 work?
right.
Now 202.1 is completely unreasonable because it's more than 100%. So it's probably either 25 or 75. So I mean, we are doing a little bit of test taking strategy stuff, but I don't think they ask. So I think they actually give you the output now, and they just ask you to match it up here.
Match it up. Okay.
So let's just quickly calculate that. I'm going to do it as well here just to confirm. All right, so it looks like 75 does work.
Okay. And I think, yeah, 10 is for the same. It's just like end behavior or what now?
Yeah, exactly. They're asking you what happens as the values get really large.
Okay.
And you could do this graphically, or you could just pick some numbers close. So close to 100 would be like 99.99 or 999. So if you're unsure, put that value in, and what you'll see is that it grows. The cost grows because there's a vertical asymptote there.
Okay.
So it just gets larger and larger. And intuitively, that makes sense. You can't really remove all the pollutants and not expect to have to pay a lot to have that happen.
Yeah.
Do you want us to look at
Okay.
11?
I think I got those.
Okay.
So yeah, that's just like the same
Same thing.
questioning.
Yep.
Yeah, so all right, move on to something different.
And you could make the case that 14, 15, 16 is really similar.
Okay, yeah.
It's up to you though. There are some interpretation questions. I don't know how many of those you've seen, the non-numerical calculation questions are just
Like 17, like
15 and
that.
yeah, like 15 and
Okay.
17. I mean, that's what would be wondering if that's clear.
I think that's just okay. Like we can try it, I guess. It's just understanding like the info and how like what's like the independent and dependent values, right?
Yeah, I mean,
Just
one thing you always do is use the solutions in the back to go backwards and just look at the solution, see why it is. But in 14, they're giving you a scenario where a clothing company is determined the average cost is given by this formula here, and they want you to answer some questions. So they're asking, well, what happens as X gets really large? Okay, and the answer here, depending on how you do it, large could mean a lot of things. Large could be 100, could be 1,000, could be 10 to the 99. Okay, you
right.
can also actually do it algebraically by dividing both of these by x. The one on the left becomes just 6. The one on the right is 1,300 over x. This one on the right goes to 0 as x gets large. Think of it as a
Okay.
1,300 is a very small
Yeah.
number over a very large number, goes to 0. So it just goes to 6.
Right.
And so what does that mean? It means the average cost as they make a really large number of shirts is very, very close to $6.
Okay.
There's this terminology in economics which says that all costs are variable in the long run, and that's kind of what's going on here.
Okay.
We'll save that. We'll revisit that when you're taking economics if you end up
If I
doing that.
do,
If you
yeah.
do, yeah. So
Maybe.
16 and 17 are similar. 16 though, the cost goes to 0. or a of x goes to 0 this time. It's a slightly different function. So that's
Mhm.
not that they always go to that one in front. They're the 6. Depends on where the variable is. Do you
Got
want
it.
us to do 16 or?
I'm going to. I'm gonna change it up to something else.
Sounds good.
I think transformations. I'll try 18.
Okay.
Vertical stretch. If I remember it. Okay.
Yeah, there's like 2 transformations here. This one and then this one.
Yeah.
The one on the outside is always vertical.
Vertical. Got it. Inside x-axis. Right.
The one inside parenthesis is the horizontal, which could be 2
Whoa.
things.
Okay.
It could be right, left, or it could be a stretch compress. But stuff on the outside is always vertical. Stuff on the inside is always horizontal. So the x plus 8 is left, and that gets you down to a couple.
Mhm.
You could always graph. You could always graph like one transformation if you're not sure, just to see it. So what I mean by that is y1 gets the 1/5 to the power of x, and then y2 maybe gets 1/5 to the power of x plus 8. If you're not sure, like if you know
Yeah.
that helps you to, if you just, but don't try and do more than one in your calculator at a time. That way you can try to get that.
Yeah. And
So this one
then
is vertical stretch by 2 and left 8.
Okay.
The left and right are always sort of not obvious. Like why does plus 8 become left 8?
yeah.
Something you've got to.
I just kind of know that one. I just need a little refresher on that. I think I'll try.
Now implied in this is that it's the horizontal asymptote.
Mhm.
But having said all that, it is kind of like right there, but you may not remember what it is until you've seen this problem. So it is always the vertical shift.
Mm.
Because that value, the graph either approaches it, or coming the other direction, but it's always going to approach that line.
The -3, yeah,
That's something you got to remember. If you graph it, you'll see it, but could take a while. I remember a student trying to convince me they could graph every one, and I said, well, you get about 3 minutes per question.
Yeah, true.
We'll see if that works.
Determine an exponential function. Graph is below. Try 21, I think.
Sorry, did you want us to do 20? I'm sorry, I went to
21.
21. Okay.
Yeah, start moving now.
Okay, let's see the form here. Okay, they're giving you the form. Just resize this a little so I can. All right, c times b to the x. You always put in the points that you're given. You actually probably want to start with this one here, 0, -2. That would be better. So that's -2 equals c times b to the power of 0. Anything to the power of 0 is 1. So c equals -2. And then from here, we put that back in. So we have y equals -2 times b to the x, and then use this next point, -6 equals -2 times b to the power of 1. Always double check that you're putting the value in for x and y and not something else. It's easy to confuse that. So 3 equals b. That goes back here. And now you have your equation. Y equals -2 times 3 to the power of x. You match that up. There it is, E. There's no notationally, there's no difference between having the exponent inside or not.
Right, okay. Uh, okay. I'm at, I think I'm gonna do 30.
Okay. All right, the style of question here is common if you haven't seen it on one of your tests where they give you multiple choice where the answers are between. The answers are never on the edge. They're always close enough to being inside there that there's no you know, you shouldn't be worried about whether it's going to work or not. Now,
Okay.
this is referring back to this other graph. So we got to go look at that first. Let me snip that in using PERT. PERT. All right, so PERT here, PE, E to the RT. Okay, and then did they give you, what do they use for Y? They use like these, they just do Y. Okay, so kind of like the last problem, it's usually best to start with the 0, 1.7. 1.7 equals P, E to the R times 0. So in this case, T is like your X.
Okay.
All right,
Yeah.
so this is R times 0 is 0, E to the 0 is 1. So 1.7 equals P. Y equals 1.7 E to the RT. And then you use this other point and you hope to find your value of R. 42 equals 1.7 E to the R times 4. To solve this, you divide both sides by 1.7. Okay, and then you don't have to do that yet because you're going to undo E. Do you remember how to do that from class?
Natural log.
Natural log of both sides.
That's
So 4R equals natural log 42 or 1.7, and then you divide by 4. So 1/4 natural log 42 over 1.7. And that, I believe, is what they're looking for in your problem. Yes, the continuous growth rate. There's no way to know if you're right. You just have to do the calculation and trust that you've entered it. We don't have enough to know if like it's reasonable or not.
yeah. So that solves, what was that, 30? Okay. I think I'll move on to,
And notice again that it fell right kind of in the middle. You didn't have to
yeah.
like wonder. Oh, because I have seen problems like that. Not good.
I think I'll try 32.
Okay. Yeah, so 32 is it's in the same class of problems that we just did, but they're not giving you the they're not giving you 0. So it's like, ah, boy, what do I do? Well, you got to try a couple of points here. So I'm going to try the first point. 4 equals C times B to the 1. And then the other one I'll do, I'll just arbitrarily pick that one. No good reason. 2 equals C times B squared. Now, you can do the following, which I don't even know if they show this, but you can take and divide them. Have you seen this?
Don't remember now.
So 2 divided by 4 is 1/2. C divided by C is 1. B squared divided by B is just B to the 2 minus 1. So notice that you've solved now for B.
Okay. That's,
Usually they
Oh,
have you do
okay.
substitution, but this works. It's,
So
shortcut.
just dividing. Interesting.
Yes. I generally choose the higher exponent on top because it's easier when you subtract. That's only B. If you had to find C, you would use one of the equations and solve for C. Like if you use this first one, I'm just showing you just in case you'd use that to find C. C would end up being 8.
Okay. 35.
Okay.
Yeah.
Evaluate. What kind of calculator are you using? TI-84?
TI 84 plus, yeah. So
All
older
right, the
version.
plus. Yes. All right.
Yeah.
Everything's a plus now. The TI-84 has a base 2. Have you discovered that? I think it's under math something.
I mean, I can add my own base with
Yeah,
yeah.
yes. And
Okay,
that's what
yeah.
I'm saying. Like this one, you could literally just enter in without thinking about anything.
Okay.
Like you can do it by hand. I'm just telling you, if it were this problem, you would just evaluate it. So this to me looks like the square root of 3. Be there. If you want more explanation, I can show you to do it by hand.
Yeah, just a bit more explanation.
Okay. So let me not do it this way then. All right. So log base 2, -4 times -2, log base 2 of 8. 8 can be rewritten as 2 to the power of 3. You do that because we want to rewrite the thing you're taking the log of, not the base, the thing you're taking the log of in terms of the base. Because you can then bring the 3 out in front. That's a property of logarithms that you'll see. You'll use that in calculus. From here, log base b of b is 1. So this part right here is 1. 3 times 1 is 3. And that's your final answer. But wait, the whole thing had a square root. So every step had a square root. Like that.
Square root of 3. Okay. All right.
You can also do this thing where you, like I said, you do it in the calculator. And then if you get a numerical value, you just type the answers in to see if it matches.
All right.
Only works on multiple choice tests.
We'll do the next one, 36.
36, okay. All right, what is the range of this function? You know, some students call this a trick question. The range of all logarithms is -infinity to infinity, no exceptions.
Oh, that's just
Okay.
the rule. Okay.
Yeah, now let me give you a little more information because I think this is important. There's 2 types of functions that you'll see. Let's talk about domain and range that are related here of exponentials and then logarithms. Okay, so we just said the range of all logarithms is -infinity to infinity. That is the domain of all exponentials. It's only the range of exponentials and the domain of logarithms that's restricted.
Huh.
Meaning we can
Okay.
talk about that if we need to, but that's something to remember. There's like a
It's just a
reference
little
sheet or
rule.
yes.
You go a little bit further into it, I guess. Yeah, if possible. But
Yeah. Can I do 37 and do because that
yeah,
sort of
yeah,
goes into it.
yeah.
So 37 is the logarithm domain problem. So the logarithm domain problem is you have to set this part right here greater than 0. You can only take the logarithm of a positive number.
Right.
You set that
Okay.
greater than 0. So this is x greater than -11/3.
Okay. So yeah, that makes sense. Cause
Do you want me to talk about the range of the exponential?
sure, yeah.
Okay, I'm going to go back to a problem where we talked about a vertical asymptote. Actually, here we can look at this one. So see how the range is bounded above by this right here.
Right.
So the range in a exponential, the restriction is it's either minus infinity to the horizontal asymptote, or it's the horizontal asymptote to minus infinity. For the log, it's the vertical asymptote to positive infinity, or it's minus infinity to the vertical asymptote.
All right.
Vertical asymptote's where it equals 0 on the inside. The horizontal asymptote, if you recall from the earlier problem, is the vertical shift.
Okay.
We could do a whole lesson on just that, but I know you don't, I know you don't have time on all that.
Not right.
But that's what it would be.
All right, we'll try 39.
Okay. Determine the values for A and B such that, so that A plus B log 3x precisely models the data shown. All right. So again, we kind of just have to use some values here. Because it's base 3, you generally would think to use multiples of 3, but log base B of 1 is always 0. So you really do want to start with this value right there. Okay, so what that means is 2 equals A plus B log base 3 of 1. So just like with the exponentials, you're substituting it in. Log base 3 of 1 is 0. B times 0 is 0. So A equals 2.
Okay.
If you don't do that, you won't get rid of A. You'll get 2 equations, 2 unknowns, which is still doable. It's just this is better.
Right.
Okay, so now we rewrite our function f of x equals 2 plus b log base 3 of x. And you choose any value. I kind of like whole numbers. I'm probably going to go that one. So 3 equals 2 plus b log base 3 of 9. But here you got to remember, well, how do I figure out log base 3 of 9? So you can go to the calculator, or remember that 9 is 3 squared. So 3 equals 2 plus b log base 3, 3 squared. Right. So just like before, that 2 is going to come out in front. And at any time, you could move that 2 over. The first 2, you can move that over by subtracting. So let's do that. 1 equals 2b log 3 of 3. Mentioned it earlier. If the base is the same as the thing you're taking the log of, the argument, that equals 1. So this equals 1 right here. That leaves you with 1 equals 2b. So b is 1/2.
Okay. So just you have to cancel out like a value or something in order to find the other.
Yes.
Okay.
If you didn't choose the first point, you would have gotten a system of equations with 2 unknowns, and then you have to subtract or substitute. They design these questions so that there's something you can do, which they call it you think of it as a trick, but it's really just, if you know the right point to start with, it reduces the problem pretty quickly.
Right. Okay. Keep that in mind. I'll try 40.
Okay, 40. Determine the inverse function. All right, so inverse always has a recipe. You start by writing y equals 7 t minus 2, and then you switch the variables.
Right.
So we have t equals 7y minus 2. And then you only way to get the variable out of the exponent is to use the natural logarithm. So you take the natural log of both sides.
Yes. Okay.
When you do that, the property of logarithms allows you to bring the exponent out in front. So it's parentheses y minus 2 natural log of 7.
Does it have to be natural log, or
No, it could be log base 7 in this case,
Oh,
but
okay.
that's where you gotta look at the
Easier.
answers and say, well,
Oh, it's
they're
looking
all
easier.
ln.
Okay. Okay.
But you're right, it could be. And if you were looking at a textbook from, well, it's been a while, 70 years ago, they probably did use log base 7. Okay, so we're still solving for y. We're going to divide by natural log of 7. And then I tend to switch the sides at some point. Add 2, so y equals 2 plus natural log of t over natural log of 7. Now, for whatever reason, they like to use this notation, g inverse of y, and you have to realize that they mean that y is now there. I think you can match that up to your answers. They don't ever have it where it's both, y and t.
Yeah, the
I don't actually like the notation they use here, but it is correct. It's just, I think it's confusing for students.
Okay. Same thing. I'll do 41. Just another one, I think. Yeah, it's just different format.
Yep. Notice all the answers are either log base something or they're not using ln this time. So I kind of have to peer ahead and see what they got. All right, determine the inverse function of this. So again, you switch x and y. X equals log base 2, 3y plus 1. First thing is to undo log base 2. You do that with the base of 2.
Okay.
And that will immediately get rid of a few answers. Like if it doesn't have a 2 to the x in it, it probably isn't the right answer. But we'll carry on here. The 2 does undo the log base 2. So it's 2 to the x on the left equals 3y plus 1 on the right. You're going to subtract 1 and then divide by 3. That leaves you with y equals 2 to the x minus 1 all over 3. Which looks like it's back to letter A. Key thing is this the undo the log base 2. It's base of a exponent 2.
Okay.
Or whatever it is. If it was 5, there'd be a 5 there.
Yeah, okay, I see what you did. All right, I think I'm gonna jump up there. I'll do 58.
All right. Okay, so to solve for x here, a couple of things to do. You could, for example, just try the answers.
Right.
I don't know if I recommend that. If you were going to try the answers, you'd want to try like 4 because it appears in 3 answers, and then maybe one else that overlaps. But let's do it correctly here. There's a property of logarithms which says that if you have the same base and you're adding, it becomes the product. The sum becomes the product.
You combine. Yeah.
So this is A, this is B. Your problem becomes log base 2, 3 minus x times negative x equals 2. So we're going to simplify inside parentheses. That's x squared minus 3x, just rewriting the order as well. Minus 3x, putting it second, minus x times x, minus x is x squared, equals 2. You undo the log base 2 with a base of an exponent of 2.
Okay.
So that becomes x squared minus 3x equals 4. You move the 4 over. That leaves you with x minus 4, x plus 1 when you factor, and you say, oh, I've got it. 2 answers, but one is likely extraneous. You need to check them. So you still have to check.
Okay.
Okay. The reason you have to check is because one of these or both of these may not actually give the right answer because it's not in the domain. So the right way to do this problem, the real like math way, is to determine the domain from the start. And the domain from the start will restrict one of these answers. Most students never do that. You know, I wouldn't have known to do that when I was taking this class. So you do just go back and check, you know, is 3 minus 4,
plug
is
it
that
in.
okay?
Right.
So what I'm asking you, and like, why is this bad? What's the problem with 3 minus 4?
It gets a negative value.
Right, you can't take the logarithm of a negative. And that's why
Right.
A is the first answer, because they know students get this and then they don't check, and then they wonder why they got it wrong on the exam.
So, yeah. All right. 60. Try that.
Okay.
I think this is roughly the same.
Yeah, looking at the answers, it suggests that you might need a calculator, but we'll find out here. So one of the key differences between this and the previous problem, besides the variables are irrelevant, is there's logs everywhere, whereas the previous problem had a number on one side. So your goal here is to use the same product, sum to product that we used before. So it's log y plus 2 times y. And now you can set the parts inside the log equal. So because it's the same logarithm, you can set those equal to each other. Y plus 6 equals y plus 2 times y. So this becomes y squared plus 2y. On the left, we're going to subtract y from both sides, subtract 6. Y squared plus y minus 6 equals 0. If you don't like the 0 on the left, I move it to the right. And now you factor y plus 3, y minus 2 equals 0. So you get negative 3 and 2. You have to check though, just like the last problem, you have to check. I mean, it's like you've done all that work, but and here's like, this is me kind of on a little bit of a soapbox here, but it's not excluded because it's negative. It's because when you put it back in, it's the logarithm of a negative.
Right.
But typically it is the negative ones that are excluded, but we saw the counterexample to that here.
Exactly. Okay.
So, you know,
it just has to work.
Yeah. So this is, to me, the only solution here is 2. And, you know, that's where if you get yourself on the test, you're like, well, is it, you know, is it A? Is it B? Is it C? No, it's only one correct answer. These are vetted pretty well by now. I mean, you're like the 15th year of students who have taken this class online that, you know, these questions are pulled from. So it's going to be right. There's not going to be a mistake there.
Okay.
All right. Probably could quickly either talk you through or give you some guidance on one more where we can stop here.
We'll do some guidance.
Okay.
All right.
Which problem would you like to look at?
We'll do 73.
73. Okay. All right, there's no way we can do this problem in the time we got left.
All right, yeah.
So good. I apologize. Yeah, that I was hoping we could do something quick. When's your test?
In 2 days.
2 days. Okay. All right.